Day 2 in section 2.4, we are still solving equations with variables on both sides. So these are the rules that we wrote down in the previous notes. If you just want to listen, you don't have to rewrite, but rules for solving equations with variables on both sides. First, we simplify both sides, which means you need to distribute anywhere you can, clear fractions, and add or combine like terms. Then we want to move all the variables to one side of the equal sign, and then move the constants to the other side of the equal sign. Then we get the variable alone by multiplying or dividing away any coefficient. So let's look at some examples. These are similar to what we did in class. If you'd like to pause at each slide and see if you can solve this on your own and then check your answer. So we don't have any distributing, we have no fractions to clear, and we have no terms to combine on either side. So what I first want to do is subtract this x to the other side. Remember, I always keep the bigger x, or the larger coefficient, in place, and I move the smaller coefficient over to it. So we end up with 2x plus 5 equals, careful here, make sure you're bringing down a negative 13. Now we're going to subtract the 5 over to the right. So we have 2x equals negative 18. Divide by 2. And we get x equals negative 9. I was noticing on the quiz that we're forgetting a lot of our rules for the signs on multiplying and dividing by negative numbers. We have a negative divided by a positive, so our answer should be negative. Okay, a little more complicated. 5x minus 3 plus 3x equals 15 plus 5x. So here we do have some terms we can combine. On the left-hand side, 3x and 5x. That's going to be 8x, and we still have the minus 3. So all I've done is combine the x terms on the left-hand side. Now I want to subtract 5x over to the left. I'm moving the 5x because it's smaller than the 8, and I would prefer to work with a positive coefficient on my variable. You can subtract the 8x to the other side. You'll just have a negative 3 over here. Now we add 3. 3x equals 18. We divide by 3 and get x equals 6. Again, 2c minus 10 equals 9c plus 4. If you're pausing the video, continue to do so. If not, try to pause here and see if you can solve this one on your own. This time I'm going to move the 2c. I'm going to subtract the 2c. Notice the 2, it's positive. Don't get this mixed up with this minus 10 back here. That makes the 10 negative, not the 2. I'm going to subtract the 2c over to the right because I would prefer to deal with a positive coefficient on my variable c. I get a positive 7. Also make sure you bring down the negative 10 or minus 10. That makes that 10 negative. So now we subtract 4 over to the other side. 7c equals negative 14. We divide both sides by 7. And we get that c equals negative 2. You may be noticing that I'm kind of flipping the c. I prefer to write the c or the variable on the left-hand side, but you could also say negative 2 equals c. Number 4, similar to number 2, where we have these two terms that we need to combine. So we have 7x plus 4 on the right, or excuse me, on the left. 24 plus 8. That also can be combined. We don't have a variable here, so 24 plus 8 is 32. Now we just subtract 4. This is just a simple two-step equation now. 7x equals 28. Divide both sides by 7, and we get x equals 4. So we had terms on the left we could combine and terms on the right we could combine before we solved. The last thing I want to mention is what happens when the variable cancels out, and that will happen. We'll look at a couple of examples. But if the values that you're left with are not equal, then the answer is no solution. So here we have an example where the variable has canceled away and we're left with something that says 7 equals 10. Well, that's not equal or not true. 7 is not equal to 10. So the answer here would be no solution. The other option when the variable cancels out is that the values you're left with are equal. Notice here we have 4 equals 4 after we've lost our variable. So the answer here would be all real. The answer here would be all real numbers. So let's take a look at an example of each. Number 5, we want to solve for x. So on the left-hand side, we need to combine like terms. 3x and 4x is 7x, and it equals 7x plus 2. Now I'm going to subtract the 7x over to the left. 7x minus 7x. Well, that's 0, or 0x. We don't write 0x, we just say 0. I also don't have a constant over here, so you'll notice the only thing I have on the left-hand side is 0. But on the right I have a 2. So here we are. We've lost our variable, it has canceled out, and we are left with two numbers that are not equal. So your answer here is no solution. Let's think about that, what that means for a second. What that means is there is no value for x. You could not find a single number in the universe that you could plug into this equation that would make the left side equal to the right side. It's not possible. If you want to try, go ahead. And then the last example, we've got a lot of cleaning up to do on the left and the right sides, so let's make sure we do that first. 5y plus y, so we have 6y minus 3 on the left. On the right we have 2y and 4y, that's a 6y. We also have the negative 7 or minus 7 and plus 4, that's going to be a minus 3. So I'm going to subtract my 6y over to the left, and I get 6y minus 6y. Those also are going to cancel out. So all I'm left with is a negative 3 on the left and a negative 3 on the right. Now here's an example where the variable has canceled out, but the two values you're left with are equal. That means we say all real numbers. And let's talk about what that means. That means that any number that you plug in for y in this equation will make the left side equal to the right side. Every single number. You could plug in a negative 2 and the left would equal the right. You could plug in 762.37 on the left and on the right, and it would solve and be correct. So make sure you know which one is no solution, that's when the numbers aren't equal, and which one is all real numbers, that's when the numbers are equal. In class, you're going to work on worksheet 2.4b.